Problem number 2931, maximum spending after buying items. You are given a zero index m multiplied by n integer matrix values representing the values of mn different items in m different shops. Each shop has n items, where the jth item in the ith shop has a value of value ij. Additionally, the items in the ith shop are sorted in non-increasing order of values. That is, value ij will be larger or equal to value ij plus 1, non-increasing. Okay, so it will be decreasing or equal for all of them. Okay. On each day, you would like to buy a single item from one of the shop. Okay, on these days, you can pick any shop I, buy the rightmost available item J, for the price, buy the rightmost available item J for the price of values ij multiplied by d. That is, find the greatest index j such that item j was never bought before, and buy it for the price of values ij multiplied by d. Note that all items are pairwise different. For example, if you have bought item 0 from shop Y, from shop 1, you can still buy item 0 from any other shop. Return the maximum amount of money that can be spent on buying all and multiply by n products. Okay. Okay, so the first thing that we should check is the range of every item. Yeah, the price of the every each shop has the value of every item. Okay, it's all positive values and it will not appear with zeros. Okay, so will be at most 10 shops and will be at least one shop, and n will be at least 1. Okay, yeah, so for each shop we can have many items. So D, yeah, like, okay, for each shop, does it have equal items? Yeah, they have equal items. They all have n items. And okay, so we will have to buy, we will shop for like n multiplied by nd, we will shop for each day, so we will have m multiplied by n days, so that we can buy all the products. So if we want to, okay, but then D on day 1, yeah, like it's non-increasing order. So if we want to maximize, on day 1, it's okay, we buy product 2. It says product 2 from one shop, from shop 1, so it's 1. We buy product 2 second day we buy product 2 from shop 0 2. Oh, then I think we should every time choose the minimum to buy. Yeah, let's see. And then we buy product 1 from shop 1. Price with value 0 2 is 0 2 is 2. And then 2 2 is 1. Oh, first buy value 1 2 1, and then 0 2 is 2, 2 2 is 3, and then we go for 1 1 is 4. Yeah, we are keep buying. Yeah, since day is big, like the d will be larger and larger, we want the largest multiplied by the largest. So like for 9, we want it to have 9 multiplied by 9 and have 81. Yeah, if we choose like, if we at day 1 we choose 8, like, oh, we choose 9, then you only had 9, the value will be only 9. But then if we make it to the last, it has 81. Yeah, and for the first day we have 1, it only, yeah, for this it's 81 plus 1, but if we reverse, it will be 9 plus 9, it's only 18. Yeah, so we have to, yeah, we will want, we will leave the larger value to the last. So yeah, let's see, it choose, I believe it choose, yeah, 0 4 and then 1 4, yeah, and then 1 3, 1 3, yeah. So I think, yeah, we should maintain a min hip, like every time pop out the minimum value, and then yeah, so we will have min hip. And we will have its size with size n and length of values. Oh, let's have m, say the shops. And yeah, we will we should yeah, the loop will be finished after every value is counted. So yeah, so every time we will choose, we will select, like, we maintain a hip with size min. So for this, it will have size 3, and it will have 2 1 3 in the hip, and then after that, yeah, after that we will, if we select one, then we will add its 4 to the next to become it. Yeah, we will add 4 into the heap. I think we can add the whole thing into heap, and yeah, and then so I think we can do it like hip 5, hip 5 values, and I want to create a class. Yeah, maybe it will be just as, not sure if this works, but I'll try. Yeah, we will select the last one to compare. So it will be a -1 smaller than b -1. And yeah, and we will maintain the money. Max spent will be 0 at first, and then yeah, while values have we see if values are yeah, like if the heap is empty, then we will stop the whole thing. So for each iteration, I would want I think this will be better if this will be length, and yeah, we have to do like when each shop has no items, we should should remove it. If I remove it, will be yeah, we should pop. Okay, so then if okay, so let's first pick the hip. So values 0 will be okay, so max up. Yeah, it says it has at least one. Okay, so max band will be values 0. It will be the min, so it will be 1. Let's add. Oh, and we should. Oh, and D should be added. D will be started by 1. Yeah, and at the end we should plus, yeah, we should not forget to plus 1 for D. And then we will have if yeah, if values 1 it still exists, then we will do hip replace values and I'm still thinking if this data structure is correct. Okay, I will replace the value for I think it's not a good idea. Like, it's kind of weird. Yeah, every time we will take the least element, so I think I'll create like value and its shop, like ice shop, or maybe ij will be better. Yeah, so okay, let's do hip. Oh, let's first have m equals the values, the length of the value, and n will be length of value 0. Okay, so then to create this main heap, I will first let's first have for loop for loop I'll say I in for row in values and for item in row. And okay, no, don't need this, but yeah, I will have the row, the last of the row. We'll have value, and then it's I need its index. So maybe not index, since I will always take the I will always take the last one, so I will have its row number. So let's have enumerate values, and then I'll have index and row. I have I, K. Then let's heapify heap. Okay. So when heap still has value, let's see. Every time heap will only maintain n rows of the row number m of m size of heap. And every time we will select the minimum, and then if that row has items, we will replace the minimum to the next. We'll pop the row, the shop item, and then we will replace it with the next value. So while heap, let's change it to heap. It's the minimum multiplied by d, and if let's say if I think it will be n minus 1, and let's have j n minus 1. So we'll have j. I think having j will be better, so we don't have to pop. And so if we will first have value I j equals hip 0, and we will have value for the spending. And if j is larger equal to 0, larger than yeah, this ij means the current value. So if it's larger or larger than 0, then we will replace value hip with new value that will be values I j minus 1. Then yeah, they will have I and j minus 1. Else it will be hip pop hip. Yeah, since if j is 0, then there is no items in this row, then yeah, we will just pop the current one, and the size will become 2. Or yeah, if like this 3, then it will become 2. Okay. And then return max spend. I think we may first use like 1. Let's see if it's equal to, I'll say 100. Okay. So m is 1, n is 1. For values, I is 0, row okay, row 1, okay, row 0, so it's 100, 0, and 0. Okay, then the expand is equal to 0 first, and d is 1. And value 100, 0, 0. Hip, yeah, the first hip. Max spend is 100 multiplied by 1, it's 100 now. So if j is, okay, j is not, so we pop the hip. Yeah, the hip currently is this only, so it will pop, then hip is empty, then we will have max spend return. Okay, so then let's maybe try run this stuff and see how it goes. So m will be, let's have m is 3 and n is 3. Yeah, so hip will be the first one will be 1, the first row, and the second number. I'm sorry, yeah, 2, and then it will be value 2, the first row, and the second number. Then it will be 3, the third, the second row, second number. Yeah, and then hip is 3, so we will run into this hip. Yeah, value ij, it will be 1 1 2, so it's 1 multiplied by 1, it's 1. Okay, so spent will be 1, and j is now 2, so yeah, it's larger than 0, so we'll replace him to value ij minus 1, so it will be 1 1. Values 1 1 is this value, so it's 4, and it's still 1, and minus 1 is 1. Okay, then d plus 2 is now 2. D is 2. Okay, so then next will be 2 now is the min. So now is value multiplied by 2. 2 is 4, so it's 5. And then it's larger than 0. J is 2, so we'll replace, this is 1. I is still 0, so 0 1, 0 row, first yeah, it's 5. Okay, and then hip will be 3 2 2 is this one, is the last and the minimum, and then it will be spend will be 3 multiplied by 3 is 9, so 5 plus 9 is 14. And then since j is larger than 0, it's 2, so we will have 1. And then for this row, the second row, 1 is 7. Okay, and then okay, so 4 will be selected. 4 multiplied by d, forgot. 16 will be 30. So this will be, change it by 0. Yeah, since j is still larger than 0. 0, and then it's indicating 8. D will be plus 1, 5. So we will select this 5 up. 5 will be multiplied by 5, so it will be 55. And then j is larger than 0, so it will be minus 1. And okay. Oh, this is 6, sorry. And this will be 8. And then it's 6. 6 will be selected. Oh, this will be updated to 6. So it's 36. Spend is 36, so it'll be added 91. And then, oh, I finally got here. So it's 0, then we'll pop this whole thing. Yeah, and d will plus 1 is 7. Then we will select 7, it's the minimum value. So 7 multiplied by 7 is 49, so it's 140. And this will be, since j is larger than 0, it will be minus 1. And then 2, 0, row 2, 0 is 9. Okay, then it's this turn. So, oh, this should be update to 8. So 8 plus multiplied by 8 is 64. So it's 204. And since j is larger, is 0, so we will pop this, and then yeah, this will be updated to 9. and we will have spent added by 81, 9 multiplied by 9, so we will have 85. And since j is 0, it will be popped. The equal plus 1 is 10, but now heap is already empty, so we will finish and return 285. Okay, correct, that's wrong. Okay, the time complexity will be Heapify is big O N, and then O M, let's say M, and then for heap selecting replace, it will be M log it will do like mn times, and each time will be log m. Yeah.